Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Is going to be presenting on work that he's done under Andreas Polze regarding the Grid-Occam project. Bernhard studied computer sciences at Humboldt University in Berlin and Germany and received his diploma in 2002. Since 2001, he's been working at Basel-Plattner Institute in Potsdam as a research assistant in the operating systems and middleware chair with Andreas. So welcome, and this is our first talk.
I'm going to talk about the Grid-Occam project. The work in this project were done by Peter Tröger, Martin von Löwes, and Andreas Polze. First, I will give a short overview of my talk. I will start with some basics about Occam, followed by the idea behind Grid-Occam. Then I'm present the results of the Grid-Occam lecture and look at some Grid-Occam programs in detail. Okay, I will start with a short introduction into Occam and the communicating sequential processes. Occam is a parallel processing language designed by a team at Inmos in conjunction with the design of the transputer processor and based on Sir Tony Hoare's ideas of communicating sequential processes. The Occam language is designed to express concurrent algorithms and their implementation on a network of processing components. The transputer processors are microprocessors with support for parallel processing through on-chip hardware and invented in the early 80s. Occam incorporates support for fine-grained, easy-to-use threads and seamless support of multi-processor environments. It can be used on shared or distributed memory systems. The strong basis of the communicating sequential processes makes it an excellent choice if formal proofs of correctness are required. The Occam language knows two kinds of statements, declarations and processes. Declarations must be delimited with a colon. And a set of processes is defined with their level of indentation, which must be a multiple of 2 characters. In the Occam program on the right, we have a procedure hello, which is a declaration because at the end of the program is a colon. And this procedure declares 2 variables, x and y, of type integer. The gen keyword defines communication channels, C and D. The type and the format of values passed on a channel is specified by the channel protocol after the keyword of. The channels C and D can only transport integers. The Occam language knows special processes. For example, the skip process, which does nothing. and the stop process, which never terminates. That means if a process is in stop, then the process is in error. The sequential process combination executes one of its sub-processes after another, indicated by indentation of 2 characters. The parallel process combination executes all of its sub-processes in parallel, and is completed if the last sub-process has completed. In the example, we have one parallel, and this includes 2 sequential processes, which will be executed in parallel. Channels supports 2 operations. The exclamation mark means writing to a channel, and the question mark reading from a channel. In the example, the first sequential process writes a value 117 to channel C and reads a value from channel D. The second sequential process reads a value from channel C and writes the value 118 to channel D. Other Occam constructs are alternations. An alternation combines a number of processes, only one of which is executed. Each of the combined processes is guarded by a guard, which may or may not ready to proceed. In the example, we have 2 alternations. First, if the channel keyboard is ready for reading, then the read value is written to channel 2 computer. If the second alternative is ready to proceed, then the read value will written to channel screen. Keyboard and screen are aliases for standard input and standard output. So the whole alternation describes a terminal. The user types some of the keyboard, and the terminal will echo it on the screen. Another interesting concept are arrays in Occam, because not only arrays of value types, but also channels of arrays of channels can be used in Occam. Each communication involves a rendezvous between an input and an output. That means a receiver blocks until the sender wrote the value, and the sender continues after the receiver read the value. In Occam, variables and channels used in parallels are subject to usage rules, which prevent them from being accidentally shared between processes in potentially dangerous ways. Variables which are changed by input or assignment in one of the processes of a parallel may not used in any other process of a parallel. A variable may appear in expressions in any number of parallel components, so long as it not assigned in any in one of the processes. Okay, that should be enough about the Occam language. There are many other interesting Occam constructs, but there is no time to present them. Okay, now we the project. The name of the project is the Grid-Occam project. Now we are switching to Grid. A Grid application can be built with different at different abstraction levels and with a number of frameworks and APIs. We want to program Grid applications at a high level, for example with Cactus. But Cactus also suffers on programming language restrictions. But in C there are no constructs to write parallel programs. Therefore, we propose Grid-Occam as a coordinating language for Grid applications. The idea behind Grid-Occam is to bring parallelism as first-level language construct to modern distributed environments. Therefore, this language must support heterogeneous execution platforms. We use the .NET platform, and with Rotor we can support macOS 10, Windows, and FreeBSD. The clear distinction of language compiler and infrastructure-dependent runtime library allows to support different granularity levels for Occam processes. The Occam compiler generates C# code, which is compiled to IL with .NET or Rotor C# compiler. We have separated the Occam program and the Occam runtime library. That enables us to run Grid-Occam programs on a single host with the multi-threaded runtime, or distributed with the MPI runtime. The multi-threaded runtime uses .NET threads for parallel Occam processes, and channels are implemented with interlocked shared memory. And the render view behavior with multiple semaphore locks. Global variables can be accessed to shared memory. The MPI runtime allows the distributed execution of parallel Occam processes. Distributed Occam processes can use the multi-threaded runtime for fine granular parallel execution. Occam channels between parallel Occam processes are realized with synchronized send operations. So far I spoke about Occam and the distributed execution of Occam processes. For the Grid Occam, we need the Grid runtime library, and we are doing research to use Grid-Occam as coordination language for Grid applications. We have investigated some requirements. External code must be supported because Grid applications are not written from the scratch. There are many libraries which will be used. And so external code could be represented as Occam procedures. The Occam runtime library should submit the Grid-Occam program to a Grid resource with standard job submission APIs. for example, a Grid Application Toolkit. The process placement is a complex task and should utilize infrastructure information and considerate channel bandwidth information and support information by the compiler. Occam channels could be mapped to web services or to grid-enabled MPI. This picture shows the proposed Grid-Occam execution environment. The Occam program is compiled to .NET assemblies, and the placement informations which are generated through the compiler step in future are used by the Grid library. The Grid-Occam executable, the program, and the used libraries are submitted to as Grid job to Grid service interface. After placement on Grid nodes, Grid-Occam processes may run on the same computer or on different computers or Grid nodes. The communication via the multi-threaded runtime can be done with on the same machine and with the web service or MPI-enabled runtime between different machines. Here, so. We have given a Grid-Occam lecture in summer semester 2004. The objectives were to build a Occam C# compiler and a distributed runtime based on .NET remoting. 5 different compilers and runtime libraries were developed. All runtimes support sequential, parallel, and alternations. Especially the Hello World program had to run as first step. In the second step, the students had to distribute has to distribute parallel Occam processes on multiple computers. The compiler construction focused on available tools like ANT, LR, CocoR, and so on. Here, one of the students generated C# code of the Hello program. We see that the parallel Occam processes are mapped to classes. We have 2 classes, parallel 0 and parallel 1, that are the sequential processes from the Hello program. And we have the program entry, where instances of these classes are created. And the Occam runtime is able to distribute these parallel classes. The second approach uses class methods for the parallel Occam processes and creates delegates for each of these parallel processes. Another complex task is optimizing of data management. On the left, we have the hello program with the variables x and y, which are declared globally. The sequential processes use these variables, and if the processes are distributed, and access to a global variable is an expensive operation, because you have to do a remote procedure call. This program can be optimized if the variables are defined and declared at the processes in which they will be used. And so an access to variable x or y can be done in local memory. Okay. Now I will conclude my talk. We have made the first implementation of Occam in Common Intermediate Language, and it will be the first implementation that uses grid computing infrastructure as execution platform. Grid-Occam simplifies parallel computation for modern distributed environments. And teaching compiler constructions and concurrent distributed programming has produced 5 compiler and runtimes for Occam subset. Questions?
Thank you very much.